have 5 teams again today. We started to create a game. They're all here ready to go. After that, we have Big MR, Echo, Street Live, and 7 Seasons Studio. So 15 minutes. Keep an eye on me and the clock for time, and 5 minutes Q&A. All of you.
Hello all. Good morning. We are Team Train and Gain, and this is our final presentation. This is our team. I am Rohit, the game designer on the team.
I'm Leslie, the producer of the team.
I'm Abhijit. I'm the 3D artist and the technical artist of the team.
I'm Simon. I'm the programmer of the team.
I'm Hui. I'm the UI UX designer of the team.
I'm Sherry. I'm also UI UX designer.
And Mo is an instructor for this semester. OK. So our client is Phil Light. He's the project manager at Boys and Girls Club of West Hill, Pennsylvania. And our stakeholders are Christine and Pat. Our project goal is to teach 14 to 16-year-old AIPI students who are taking an artificial intelligence course in the summer and helping them understand the concepts of neural networks through the interactive visualization of a self-driving car. So neural networks, like we talked about during the House presentation, is a really complicated concept and has its own challenges when it comes to teaching them and also from the perspective of students understanding the concepts. So for us, it was really important to have a direction in terms of what we wanted to do in terms of design. So we chose to move from simple to complex, which sounds super obvious, but really helped us to to channel what we really want to accomplish from this project. So the idea is to break down the neural network to its simplest form and just focus on the vocabulary and the terms related to the network and not think about the complexity and the structure just yet, and gradually increase the complexity and teach the students different concepts and take it to a level that is not solvable by the students. And that's where we reinforce the complexity that in real life, neural networks are indeed really complicated, and it's not easy to compute the mathematical problems that they go through. So this is the whole idea that we're basing our game on. I would like to call upon Abhi to talk about how we are doing this in the game.
Thanks, Rohit. So as Rohit mentioned, the design of our game was to have a progression from simple to complex. So let's go through it. The game begins with an introductory video lesson that tells the students about the basics of neural networks, some of the vocabulary, and it serves as a recap on whatever their students have studied in the AIPI course. And it also introduces the concept of neural juice, which we later on use in the game. So after that, the students are introduced to this structure of a neural network, which has just one input, one output, and one weight. And it has a lower weight range from -1 to 1 that the students can control, all discrete values. And so in this, basically, the students focus on the relationships between inputs, outputs, and the weights, and how they relate to each other. It also helps the students understand the basic visualization of how the data flows through the system without worrying too much about the detail. After that, we still keep the basic structure, but we add another input, and we increase the weight range from -2 to 2, again, all discrete values. And this, again, helps the students to understand how the weights affect each other and the output. After which, we move on to a much more complex structure with 4 inputs and a much larger number of weights. So this, again, reinforces that complexity that neural networks can be really tough to compute, and which is why we need machines to build and train them. So to reach a final product, we went through a lot of design and tech iterations. So we'll go through them. So for the 3D part, we went ahead with the voxel art style because we wanted to keep the poly count really low. And since our game is heavily dependent on particle systems and runs on WebGL, again, we wanted to keep the loads on the browsers low. And we tried to match the color palette from 3D and the 2D UI to keep the whole experience a bit more cohesive. So I would like to invite Shireen to talk more about the 2D UI part.
Thanks, Abby. I will introduce the design part. Our game is combined with 2D and 3D part. Because neural network is really hard to explain, so we made the 2D part looks like a network which you can control and visualize it in a 3D way as a self-driving car. And we did a lot of design iterations. At first, we want to split the screen, and we try left, right one, and also top and bottom one, and we settled down on the left, right one, because in this way, the players can view more of the screen. And we also improved our UI design style because we want our UI interface to be consistent with the 3D art. So we used neumorphism. This kind of style combines the colors, shapes, gradients, shadows, and highlights all together to ensure graphic intense buttons and switches. All this allows achieving a soft extruded plastic look and almost 3D style looking. We also changed the view angle because we want the players to think that they are playing as an AI, not just watching AI perform actions in the game. We want the players to be more immersed into the game. The most difficult part is the button change. We tried many versions, from simply listing out the number selections, then visualizing it in the shape of a valve. But after multiple playtests, we found that the players tend to click the buttons rather than dragging it. So we changed it to a clickable button. And also, as the difficulty of the game increases, the numbers of the valve also increase. So we added more colors to the valve and finally go with the last version here. Next, I will hand to Hui to continue talk about design iteration.
Thanks, Sharon. So although we changed the weight buttons lots of times, it's still a big challenge for us to help the client learn to adjust the weight and understand the importance of the weight buttons. So our goal is in the first level, the client learn to get the weight, and in the second level, the clients, they learn to adjust the weight. However, during the playtest, we found it's difficult for the playtesters get to know how to adjust the weight in the second level. Then we sort of upgraded the weight buttons in order to make it easier for the audience to understand how to adjust the weight and notice the upgraded weight in the second level. So to better compare the two weight buttons, we use this red version. Our next design challenge is a neural network graph is a terminology in itself. How to make the target audience remember it and understand it. We came up with putting it in the introduction video and tutorial pages. However, during the playtest, we found the clients, they still cannot get that and remember it. Then we add one more explanation way, it's the structure map and the Hoover function to help the client understand and remember the neural network terminology. Therefore, the test cases was the last feature we added, because in our final meeting with the stakeholder, Pat, he highlighted the most important thing to include is the error. And because this is how the neural networks corrects itself. So after various attempts, we decided to use the playtest to show the errors and use the errors to help the clients as a hint to help them continue the game. So next, Simon will talk about our tech part.
Thank you, Hui. For the tech part, we are using WebGL plus Unity as our development platform, and it is accessible in any desktop platform with a browser. So this combination allows us to make updates and flexible supports, and we'll make the most use of the existing course material and devices of AIPI students. And we tried parallel working style to increase the efficiency in our group. So we start by making a very fast prototype when our designers are making the delivery of the neural network. So this is like the training process of the neural network. And later, after we introduced the concept of the self-driving cars to visualize the output, we have the second iterations. And this is the thing on the right is used by a render texture rendered by a camera on the traffic scene. And this design is later used in all of our iterations. And after we get the concept of neural juice, which indicates the data flows in the neural network and the valve that controls the importance of the input, we got this design. And on the right is a gameplay scene, while this takes up only a small place in game scene, and the students will not feel very immersed about it. So we later changing to these iterations, and we make the monitors full screen, and the canvas on the right is transparent, so they can still see the traffic scene while adjusting the weights. And finally, we changed the camera's view from the side to the back of the self-driving car to make students feel more immersed about it. So we also have experiment with two liquid methods. They are all based on the Unity particle system, while the one on the left is the default one, and the one on the right is using a script camera to make the effects of the liquid. Due to the consideration of performance and the programming issues, we are using the one on the left. Yeah, so now I will hand over to Leslie to talk about the final deliveries.
Thank you, Simon. So after numerous iterations of design, our final deliverable consists of an introductory video lesson and a WebGL game, and as well as the teacher resource guide and the curriculum evaluation. So the teacher resource guide is designed for IPI instructors in order to help the experience run smoothly in their classroom. Our resource guide includes the requirements for the device and a detailed walkthrough of each level, as well as the tips on how to use the game in the class. The curriculum evaluation is designed for clients to better develop their IPR course and to evaluate how well students learn this course. So during the whole semester, our game have playtested with over 40 people aged from 11 to young adults. The latest playtest was with IPR students. So during that playtest, we found that only 25% of AIPI students have the pre-knowledge to neural network. However, after playing our game, 83% of them better understand the composition of neural networks, and 70% of them answer the questions we asked them correctly. So the question is especially about how the weights works in the neural network and how important of different weight influence the different inputs. So based on that, we confirm that our game successfully conveyed the basic knowledge of neural networks, such as its basic structure and the function of weights, the relationship between inputs and outputs, and weights, and training process, etc. So other than that, the project still has a lot of room for improvements. For example, we can try to explain the concept of activation function and using the similar design language. We can design more scenarios for the car to go through to add more fun. We can also increase the number of nodes to add more layers for students to explore. If we have more time, we can add all the above to our project. So all in all, our project have a very fruitful semester. We want to give our special thanks to everyone who helped us along the way, and especially all the teachers and students who gave us their time and expertise. So in conclusion, we are training again. We are making a transformational WebGL game to visualize the neural networks and help the IPR students better engaging in the IPR course. Now we are open for questions. Thank you. Yes, Mike.
So I like that you have advanced levels now. Will you share the link so we can play those? Because at SOFT you didn't have 4 things. Is that ready to be played by everybody?
Yes, it's on the WebGL link. So you want us to go out?
So if it's in your project website, that's right. We can link the WebGL link. And then the question is, if the weight is 0, do you turn off the neural juice for that input?
Yes, we did. So we not only just stop the neural juice, the particles flow into the container, we also have the hint to students that 0 makes the neural network confused.
Okay, yeah. Your animation still showed juice going through at 0.
There will be some small limited amount of the particles, but the whole result is that not flowing to the container.
So why is there a small bit? I'm pushing on this just because if your range is -1 to 1, 0 happens a lot. And an important lesson is set the weight to 0, ignore that completely. So I think the visual lesson should be the weight to 0, nothing's happening there anymore.
Yeah. And
So for the weight of 0, it's like the color of the neural juice becomes the normal color, like blue. Yeah, it does not
I don't
affect.
even care about the color. I just want nothing coming out of that. Nothing, because we're ignoring it. 0 equals ignore the input.
so
And I just think the visual signal should be really strong. We're ignoring the input.
Yeah, so for the scenario I was saying is that for the single input, if that weight value is 0, then there would be like limited amount of particles. Yeah, but if the 2 inputs and their sums up is 0, then is the whole thing flows into the container and the color is blue.
Yeah, and you did that well. Summing the 2, if it's 0, you explain it and color it, but that's all fine. I'm just saying, any particular gate, if the weight is 0, communicating that to ignore it, I think is important.
Okay. Yeah. Yes, Bob.
So for the inputs and the outputs of the neural system, what are they exactly? You had an X input. What does that signify?
So the question was, what are the inputs and outputs and what do they signify? So in the slides, if you see, so the inputs here are the sensors that are on the self-driving car. So we explain the scenario while the students are playing the game. So in this case, one of the cases, it would be a green light sensor. So when the car encounters a green light sensor, juice starts flowing into that input pipe. And the output, based on the color of the output, is if the car goes or not. So if the output is green, the car goes, and if the output is red, the car stops. So based on the adjustment of the weights, the students have to find the correct set of weights to make the car go or stop based on what input is given to the car. Yes, Chris.
On your playtest slide, you talked about how a certain percentage had understood the concept. And on the right-hand side, you had talked about the numbers that came out of the quiz, right? So what assessment technique were you using to determine understanding the concept?
Yes, so we made a 2 kind of survey. One is before the playtest, one is after the playtest. So we asked them about the specific questions related to neural networks and to see how much they learned before the playtest and how much they learned after the playtest. So the question is something like if the weight is some certain numbers, for example, 1, what's the weight for the other one, and to see whether they understand the absolute value, the weight importance, something like that. Because those, yeah.
Both methods were a quiz?
Yes. Yes.
Okay, that wasn't clear. Thank you.
Time for one more? All right, thanks, team.
Thank you.
Thank you very much for your patience. We've just got some technical difficulties.
This is our goal.
So sorry for the delay. So welcome to the final presentation of the Big MR. I am Hui Jiebao, the designer and producer.
I'm David. I'm a programmer on the team.
I'm Nolan Pearson. I am a designer and I also helped produce this project.
I'm Alyssa Tang. I'm also the programmer on this team.
So our clients are basically all from ETC, have Ricardo, Steve, Brian, David, and John, and our instructors are Heather and John. And what is Big MR? Big MR is a platform that we are going to let creators to create a Big MR experience. So what is Big MR experience? It has 4 features. The first one is big room. We are using a 30 feet by 30 feet physical space in the RPIS. The second one is multiplayer. With up to 15 people in the same room at the same time. Then it's mixed reality, which including the Quest 2 pass-through camera, which can blur the mixed reality and virtual reality and the real world. And the final one is object tracking. We are using the Vive trackers as our object tracking, but we also explored other systems in these masters. So the metrics of Big MR, including the technology, which is a platform with hardware and software, and the documentation, which including the design doc, tech doc, and startup setup guides for the future team or people who want to develop a Big MR experience. Then it's prototyping. We have developed 2 demos which covered all the 4 features of the Big MR project. The final one is innovation about how to utilize the big room and the big multiplayer and mixed reality. Then let's Nolan talk about the inspiration.
Thank you, Reggie. So some of our inspirations for this project was a previous ETC project called Impressions. This was an art therapy program using remote VR headsets. We looked at their dev blog, saw what they had learned and what we could incorporate in our project. The second example we have here is a game called Space Pirate Trainer for the Quest 2. This was a local multiplayer game, cooperative, in a 30 by 30 foot space. We wanted to look at what their design considerations were, what they thought about health and safety, having 2 people in the same space. And the third example here, we received a lot of input from our clients. One reference we had heard regularly was the holodeck from Star Trek, so that is something that we tried to emulate with this technology. As Weijie said, the deliverables for this project, the platform is a combination of hardware and software and rigorous documentation. We wanted to make sure that another team could pick up where we left off and they would know what we know now and could improve upon that. And our tech demos, we also wanted to explain and explore what this technology could do and show examples of that. And we also wanted these demos to be jumping points for other projects. Our main target users, our client really wanted us to create something unique for ETC students to use, akin to the JAMO drum or the cave, just something that students wouldn't otherwise have access to, something unique that they could use. The pillars of Big MR, the pass-through camera must be enabled. This is what is allowing us to blur the lines of reality and mix different visuals. A networked local multiplayer, this just encourages and reinforces engagement of a shared experience among the guests. And object tracking would allow us to use alternate controllers, props, or tools that guests could share amongst each other, further reinforcing this engagement. Our primary design principles, this was sort of the hypothesis that we went into this project with. Health and safety first and foremost. We knew that the guests had to be 100% confident in what they were seeing and what they were doing. The syncing and the calibration had to be perfect. We wanted to encourage guests to move around this space, and so we wanted to make sure we were not misrepresenting the space or obstructing objects in any sort of way. An example of this that we found out early on in one of our tech demos, we had used a pre-rendered scene that had a dip in the floor. Even though our guests knew the dip was not physically there, just visually perceiving it, we noticed them avoiding this and walking around it, so we wanted to make sure that we avoided that. And I will hand this over to Alyssa to talk about the demos.
Thank you. So for a quick recap on what we have done before halves, we got our headsets networked, and also we got the web tracker synchronized, so we can do object tracking based on that. And also we built a door portal demo using this physical improv door, so the guests can enter or exit the VR world by passing through the door. So after half, we were mainly working on improving the stability and also the speed of the tech. And also we built 2 tech demos to showcase the feasibility of our platform. So the first one is called a Cube Portal demo. Yeah, so we can see that we set up 4 doors linking to 4 different scenes. Some are fully decorated VR scenes, and some are just objects floating in the air. And by stepping into the portal, you can really enter the VR world. Yes, so by entering the portal, the whole RPS room will be decorated as the VR scene. And we also worked on the effect that when you look back into the portal, you can see the real environment you are in. Yeah, so this one shows how we can obscure the boundary between real world and VR world. So this is building a mixed reality experience based on that. So the second demo would be showing our function on the locally networked headsets, and also we built a collaborative painting demo that requires multiplayers to work together. So like on the bottom left is recorded in Nolan's view, and on the bottom right is the up-down view to the canvas. So the players share the same canvas, and they can paint on that together. As we can see that Nolan can see that Chen Guang painted something red on the canvas, and also he himself painted a black bug, and later on that David would add blue color to it. Yes, and we got the colors to mix together. So all of this happens the same in every player's headsets, and also they are able to see each other's headsets floating in the air, that they are synchronized in the same network. And also we intentionally give each of them just one color to encourage them asking for help and collaborating with each other. And after that, we improved this demo by based on the feedbacks we got from our playtesters. Special thanks to Michael Crystal, we got our canvas transparent so that it will not block the view. So now the players are able to see the whole surrounding environment as well as other players' full bodies. So this will make it safer and also easier to adapt to for those with less VR experiences. And this video will show another version using the wave trackers as the painting brush. Like in the video, the brown brush is attached to wave trackers. So before that, when we were using controllers, the players are not encouraged to share it with each other because it's kind of linked to the headset. But now with the wave trackers also synchronized in this network, they are able to pass it over to other players and share it on the canvas. So in this demo, we can see that we successfully synchronized our headsets, controllers, wave trackers, and also the VR scene we built. And this indicates that we are capable of supporting more designs involving object checkings in the future. Now I will pass to David to talk about our playtest.
So during our playtest day, we showed our guests the painting program and the portal program. So we ran the portal in the morning and the painting in the afternoon. And one of the unique things we found during the portal demo is that people really enjoyed walking through this portal that was in front of them. But we got more valuable feedback out of the painting demo in the afternoon. So we can see on the right here, we have this painting that this group of three, a family, drew together. And they really enjoyed this cooperation between them. The fact that they each had one color helped to enable collaboration and make sure that they were able to paint something meaningful together. So here we can see just some drawings that we've had over the course of the semester. We can see in the top right, we have one painting that actually has 4 different colors. So that was a playtest where we had 4 different people collaborating together. And during softs, we were able to get 6 people into the headsets and paint together. So we had 6 different colors and people cooperating with each other there. And what we learned from all these playtests is that we've really worked on streamlining the setup and onboarding. So originally we had to connect all of the headsets first and then sync all of them in order and then hand them to the guests. So this was causing a lot of downtime for people standing around. So instead we opted for a method where we would connect a headset and then hand it to a guest and then connect the second headset and so on, so that fewer people were standing around and we were getting people in as fast as possible. In addition, we wanted to design for guest comfort, including mitigation of latency, so that objects in the space would map to their real-world counterparts as accurately as possible, as quickly as possible. And again, as Nolan explained earlier, making sure that there are no false sense of where people can step or touch things in the physical space. And we also found that this transparent pass-through overlaid on top of the canvas, it boosts people's confidence in the situation and allows for more engagement between guests. And the acoustics of the room really helped people to cooperate with each other, because the interaction between guests was with their voice in the real world rather than having to emulate using a microphone. So in general, throughout the project, we believe that if we had established our goals and deliverables earlier on than we had, we would have been able to accomplish more throughout the semester, which is just something that we had to discover throughout. And again, at the beginning, we really set out to create one full experience incorporating all of these features, but we ended up creating 2 different prototypes showcasing the different aspects of the project that we were working on, and we believe that helped us hone in on what the actual prototype was supposed to show. And of course, last, to stress test the system often, we had many times where we would book time in the RPIS, come down to test, and there would be some glitch or hiccup. And if we had stress tested it more earlier and more often, then we would be able to iron out those bugs quicker. And I'll hand it to Weijie to talk about our plans for the rest of this week, actually.
So on May 5th, this Friday, we will run to the Jefferson Front, which the theme is Navigating the Unknown, to present a multiplayer painting demo. So we will have 15 people per round at the same time in the same room on the same canvas. And in order to do that, we went to that location of the hotel last Wednesday to playtest with 7 headsets and the network and their staffs from the foundation. So the future of Big MR with the colorful pass-through camera and the ALP system to be ready, we can have future team to create one entire experience based on our documentation and the project. So in summary, Big MR is a project about explore hardware and software to let creators to create a Big MR experience with large space, multiplayer, pass-through camera, and object tracking. Thank you.
Yep, Chris?
Yeah. Would you say that your project was more exploring the technical space or the creative space, and why?
I would say that the first half of the semester before halves was more exploring the tech space. And then after we had established the criteria of the tech using the pass-through camera and the Vive trackers, we sort of moved into the design space to see what we could use with the tech we had established. And so that's where the painting demo came from out of that after halves. Yeah? So one thing that actually we heard from Jesse Schell during Softs was that he said this was the first cooperative AR experience he'd had, which we think is a benefit to the system in that this is unique, that people can see each other in this virtual world. And we think that the painting demo itself is a very bare bones mapping of head and hands and just a canvas around people. But in the future, having a more fleshed out environment will allow people to feel immersed in this virtual world, but together with other people. Yeah, Mo?
When I step through the portal and immersed in the city, how do we represent other players or physical objects that might be there, and do we even care about that problem?
So one thing that we found during Playtest Day, running the portal demo, is that when people stepped into these, when people stepped into the 2 scenes that were the RPIS with objects in them, people felt a lot more comfortable walking around and interacting with the objects in front of them versus the 2 scenes that were completely obscuring their vision, which automatically people were uncomfortable. They didn't know where they were in the RPIS anymore. So that was one of the things that we found actually during Softs, where we had the canvas of the painting demo actually obscuring the vision of the rest of the RPIS, and that is where the solution of making the pass-through transparent came from. So I believe if we went back to the portal demo and added that transparency, it would enable people to feel more together in that VR space. Dave?
if this were a platform in BBW in the fall, what advice would you have for the TAs who are supporting it? And I guess what advice would you have for the students who are working with it?
So if this were a platform for BBW in the fall, first recommendation would be to trim down the number of features, so automatically cut the vibe trackers. So just co-located networked Quest 2 headsets. And also making sure that the experience enables cooperation between people. One thing we really harped on during the painting demo was making sure that people were collaborating with each other. A lot of times we had people say, well, how do I switch colors? And the answer was, well, you talk to other people. And I think that if we had leaned into that, of allowing people to switch colors, that people would go off into their own corners of the space, and it wouldn't be as much a collaborative experience as it would be just painting, but in the same room as other people. So those would be the two big things.
Time for one more.
Eric?
What's the scalability of the platform? I saw you say Playtest with 4 people, 6 people, or even you are planning to do 15 people. Is it possible to do like 100 or even more?
So the scalability of this system is really dependent on the transmission of data we found. So because we're using Quest 2s and they're inherently networked over Wi-Fi and our servers on a PC, we have to transmit that data. And with our painting demo, with only transmitting the positions of a head and hands, that's very limited data. But the more people you add to the system, the more components you're trying to track, the more information you have to send over the network. So the scalability is really dependent on how fast you can transmit that and the server load that it can handle.
All right, thanks, team.
Hello, everyone, and welcome to the final presentation for Team Echo. Here's our team, which consists of myself, Sarah, Shunan, James, Danny, and Jingyuan. Our faculty advisors, Brenda and Dave. And our client for this project is the organization Games for Change. Games for Change tasked us with delivering a transformational game experience that will be showcased at the Games for Change Festival this July. Our client had a few goals they wanted us to achieve for this experience. First, we should focus on a topic that's rooted in the broader scope of environmentalism. Second, we needed to empower our guests to make change rather than feel hopeless with these issues, which can be a common problem when dealing with environmentalism. And lastly, we wanted to aim to foster a sense of community between our guests so that they don't only feel encouraged to make change individually, but together as well. So in order to achieve the first goal, which is to pick a topic rooted in environmentalism, we did some research and narrowed down our topic to eco-friendly fashion and sustainability, which we'll discuss more in depth later on. And then after we chose our topic, we were able to identify our high-level purpose, which is to create more eco-friendly shoppers.
And so going on to our other clients' needs, we wanted to, again, go with the context that we're designing this for the festival experience. So some of the things that they had wanted were to have us play about 50 participants during the festival. We would get a chunk of about 90 minutes that we would be able to run. So if we wanted to run all the way up to that or sometime within that, that's the amount of time that we had. and for a focus on a general asynchronous experience where it wasn't just limited to the experience going on at the physical festival, but that we may have other options as well. So dissecting those a little bit, we were able to break up the number of 50 people originally into smaller groups, and because of the festival's multi-day nature, we actually decided that we were going to run over 2 days, and by doing it over 2 days, we're now running about 24 people in smaller groups on the first day and then on the second day in comparison to a single 50-person session. Moving forward, we had made multiple iterations of the festival layout. This is something that's still somewhat in flux, so there are attributes of this that are changing, although we're still relatively sure, and as iterations change, we still had the general model of about 4 participants around a table or a shared screen with using their phones as controllers. And then we had done an example flow. Again, this may change, but this is an example flow of how guests would go through our experience. And then followed by the asynchronous availability. It is available on our website, so we actually decided that we were going to make our full game, which is Terra Thrift, available on our website. So the game itself, as well as the material guidebook, a resource that we made to assist with learning within the game, we've made that available on our website, so anybody would be able to go to our website and play with just 4 people and phones on there. And so now we have a gameplay demonstration of what Terra Thrift is. So as you start the experience with the 4 players, you would start getting into this screen, which is going over what the tutorial of the game will be like. There are 2 phases of the game, a tutorial and then a play phase. The tutorial explains what the different attributes of fabric sustainability are, and this is a tutorial for the tutorial that explains how playing with the Air Console controllers will work. This is an example level in our game where each player is assigned a garment which has a different description, different attributes, and they're trying to move themselves along this scale in order of recyclability for this first level. Different levels would talk about different attributes. Communication is encouraged, so it's not just something that you're able to do on your own. You need other group members to work together in order to beat the level and move on to the next one. In the event that you get something wrong, there's a hint, and once you've beaten all the levels, you'll move on to the play phase. During the play phase, you're working as workers of the Terra Thrift Eco Shop, so you are in this 3D environment, and you are able to listen to these customer requests, pick up garments, getting attributes about them, getting a description of them, and then try to match the customer with their wants. All right, and so that's where we are, where we're trying to be for the festival in July, but how did we get up to this point?
Thanks, James. We are going to introduce our process through 3 parts: design, art, and technology. And I'm starting with the design part. So, speaking of the fast fashion industry, what comes to your mind first? I guess most of people will think about all the fancy clothes that's shown on the stage, or some fast fashion brand like Zara or Forever 21. But have you ever thought what's behind the fast fashion industry? It actually looks like this. After all the clothes end as their life cycle, they go to a huge fabric waste mountain. In fact, the United States generates an average of 25 billion pounds of textile per year. 85% of fabric goes to landfill, and only 15% of the fabric goes recycled or reused. And this textile can take up to more than 200 years to decompose in landfill. So it will be a severe environmental problem in the future. And that's why we are going to create more eco-friendly shopper, which is also our high-level purpose. But how we are going to create more eco-friendly shoppers? We need to find those hidden barriers behind their shopping behaviors. We need to find out what actually prevent them from being an eco-friendly shopper. So we did some additional research, and we also interviewed some subject matter experts. From our research, we focus on the clothing labels. Because checking label is not a common behavior in shopping, so people won't be aware of what the clothes are made of and how to recycle the clothes. And that's why it comes to our transformational goal. We want to teach guests how to read clothing labels. By teaching guests how to read clothing labels, they are able to know more knowledge about the fabric and also the recycling process.
They are able to self-identify eco-friendly materials used in clothing. And also, we may change their behaviors. They can check in more labels and choose more eco-friendly options when they are shopping in the future. Finally, they are able to grow curious about eco-friendly brands, stores, and other accessible options. They may think that eco-friendly is a new fashion in the future.
So we initially tackled the teaching of reading the labels and deciphering the eco-friendly materials by doing a paper prototyping of a thrift shopping experience and an informational guidebook of the different materials. And one information that we found from the prototype was that the participants who playtested took a significant amount of time in understanding all the information and using the information to play our game. So now we found a need for a separate game phase, which we call the tutorial phase, where we teach the players about the different materials and the level of recyclability before the players can go through the thrift shopping experience, which we call that the play phase. We also had a physical and a digital version of the material guidebook, and we incorporated the physical guidebook as part of our game experience. And the reason for us doing that was so that the players can physically touch and feel the different types of fabrics that are attached onto the guidebook, as well as use the information to help solve the game. And the digital guidebook is an extended version of the physical version so that the players can take a look at more information after the experience. So overall, we hit the 3 transformational types, first of all, by teaching them the knowledge of the different materials and their level of recyclability in the tutorial phase with the use of the material guidebook. Preceding that, we are helping them to change their behavior by in the play phase by helping them implement the information that they learned in the tutorial phase. And after that, wrapping up our experience with a downloadable file of the digital guidebook in the hopes of helping them continue on thinking about our game after the experience. So as for playtesting, we focused on looking at these 3 goals. We were focused on looking to see if our game met our transformational goal, if the art had clear visualization and was easy to understand, and if there were any technical issues that we needed to be aware of. And further details we discussed as we transition into art and tech.
And next, we're going to talk about the art in our game. And first, based on the theme of Games for Change Festival, we try to add another eco-friendly vibe by referencing different kind of local thrift shops. And we designed a space that is very confined for multiple players to work as a team. And we changed their roles from customers to staffs. And this change allows them to focusing more on the close information rather than showing their personal preferences. And we choose pixel art as our game style for several reasons. First, we want to provide a nostalgic vibe for our potential guest demographic, like game developers or educators. And we also believe that pixel art have a strong local community vibe and give us a handmade touch to our games. And 2D art also contribute to different kinds of narrative and art transformational goals. For instance, we have tutors and shop manager throughout our tutorial mode, and we change our information box into labels. And after playtesting, we change our user interface by exposing all this closed information onto the share screens. And this allows this player to talk through their information easily and compare with others. And this also allows our phone controllers very clean and work consistently as controllers. And we also try to have a tightened connection between our characters and their close informations. So we design a very specific color and assign a very specific color pattern for them. And for our 3D art, we use Magical Voxel because it has very ability to do very fast iteration on our environment. So we try to desaturate the surroundings and add different color palettes to our interactable assets and areas. And at the end, we try to add some distinctive assets for the surroundings, but without misleading where is the playable area. So echoing our transformational goals, we try to blur the 3D art clothing informations for them to check in more on the clothing information, sorry. But it also shows that for the customer, we have multiple playable options and encourage them to explore this very small eco-friendly shopping environment. And other part of art focusing on giving them a happy ambience for them to talk and learn. So we have very distinct colors for the characters and also give them different kinds of visual and sound effect feedback after each sections.
Next, I'm going to talk about tech and implementation. So looking back to our goal, we want to create a game that makes a change, foster a sense of community between the guests, and allow everyone to participate easily. Therefore, we choose Air Console plus Unity WebGL as our platform. Air Console is a great platform to implement multiplayer experience in an accessible way by using our phones as controllers. It also enables the audience to play both in person and online. When developing our games with Air Console, we faced a few challenges that come with the platform. One implementation challenge is that every individual player can have their own controller view. This can be used for something as simple as displaying the player color, but you also can convert individual information such as different colors and text. Also, it is a powerful advantage. It means that we need to send different data to each player's phone and display correct information for them. Second challenge is that for multiplayer game, players often encounter bad network condition and disconnect from the game. In order to solve these problems, we need to implement reconnection when players disconnect from the game. Since it is challenging things, we need to correctly identify which player is reconnecting and resume internal data for this player.
Thank you. And so again, this was all leading up to our demonstration, which will happen again in July. We will be there from the 13th and the 14th as displaying at the festival where our game will debut. And again, it is not just ending at the festival, anything like that, so we want to make sure we really are leaving users with options for more resources, for things that, directions they can go to learn more about what they're trying to do, specifically in regards to fashion sustainability, and the material guidebook, again, being available online for anybody to look at. So again, here is the summary of our project. We are the ECHO team for Games for Change, where we're debuting a game at the Summer Games for Change Festival about fashion and fabric sustainability. We want to say a big thank you to all of our playtesters and faculty, especially Dave, Brenda, and Heather for all of their assistance. And now we would like to open the floor for questions. So currently we have the game specifically at 4 players. We have gone through a few different iterations where we allowed different player counts. We found at 4 it was the right amount of communication along with player agency. So we can, dependent on our clients' needs, make changes to that. However, based on what they had expressed, we found 4 to be the right player count.
And how do you group the players into a unit? Practically, how does that happen?
At the festival specifically? So that's one of the things that we have decided as part of our plan for the festival itself that was not necessarily part of the game experience, but we are designing a plan for how we're going to sort them. We are gaining additional knowledge from both our clients as well as Games for Change attendees about their sort of habits for whether they're coming in groups, coming as solo, but part of the flow that we had mentioned earlier will be sorting them into groups potentially. We found that if we are likely to support them if we are likely to put them as individuals into a group where they know nobody else in the group, it's possible that they are less likely to communicate because they are not as social. However, we want to try to not necessarily have it be just groups of 4 who have come together. We want to have it be more mixed in such a way where they are able to communicate with people they already know while also getting to communicate with new people as well.
Technically, does each group have a code or something? How do they connect to each other?
Oh, yeah, so there's a shared screen on each of the, for each group that'll be running each individual session. So we are attempting to launch every game at the same time with general instructions. However, they will be able to play at different paces and everything. So there'll be individual Air Console lobbies.
No, we do not have any type of reference, I guess, to the landfill. We wanted to aim more at, instead of, I guess, throwing a lot of that information at them, since our client wanted us to empower people, we decided to instead give them information we thought they could use and go out and use when they're shopping. So instead of, I guess, throwing sort of this, like, sometimes looking at that can be sort of overwhelming to people. So we thought if we gave them information that seems very not easy, but digestible to use as they go out through their daily lives, that's why we didn't focus on that specifically in the game itself, but use that as like a starting point for why this was important.
And we wanted them to focus on the whole process of the recycling material, like the life cycle of your clothes, and what they may be more aware of how your clothes ends after their life cycle. And that's the part of relation to the landfill.
It seems like your game does a very good job of creating awareness about sustainability, but 90 minutes feels very long to be sharing ultimately similar information.
So the 90-minute window is not something that we are taking up all with gameplay. Our goal, because of the festival nature, would be to introduce the game in some amount of time. The actual gameplay, I believe we've generally clocked it somewhere around 30 minutes or so as the actual gameplay portion, but with trying to capitalize on having people in person, having people able to communicate with each other, use the physical guidebook, we want it to be an introduction and everything, starting to socialize, and then playing through the game, and not necessarily even trying to complete it as quickly as possible, but just working on communicating, and then a debrief at the end that would also have to be included in that 90 minutes that would not be gameplay. So the 90 minutes includes the whole experience, not just the gameplay experience.
All right, that's time. Thanks, team.
Hi everyone, we're Team Streamlining. We expanded the Snowball application created by two CMU faculties, Jessica Hagen, who work with Robotics Lab, and James Dusing, who work with College of Fine Art. Ruth and Tom are our two instructors. And then let me introduce my wonderful team members. Hagen and Ray, our two 3D artists, worked on animation and texture. Peter and I are UI/UX designers, worked on UI system. Cleo and Robin, our two programmers, worked on machine learning and pipeline implementation. So what is Snowball? Snowball is an immersive theater application. Users can go out, search on real-life street while exploring an augmented reality neighborhood where characters called Spock live there. The goal is to have users go outside and scan common objects like fire hydrant, parking meters, and stop sign on the street, and explore their neighborhood and characters' storyline. In the past semester, we expanded upon the Snowball app our client gave us. The programmers worked on improving the performance, adding the new features to the app, and our UI/UX designers focused on designing the guide experience and also updating the user interface. And our artist provided a character customization option with swipeable body parts.
And now I'll be doing a live demo to show you what this project really is. So I first open the app, and I get to create my own snob. So there are 3 combinations for each body part. And for this presentation, I think I'll be using this combination. So basically, this app consists of 2 tech parts, machine learning and augmented reality. The machine learning takes the camera view as input and do object detection on it. And once the object is detected, the AR puts an animation near the object. So take this as an example. The camera detects the floor, and the augmented reality just put this stretching donut guy on the floor. So this is the first animation that players will be seeing. And some bubbles show up. When I click on it, it tells me to find a fire hydrant, which we happen to have one in the RPIS. And when I get closer, I can see that something's scanning this, and the snob has arrived. So let's see. It's a little far away from us, but so yeah, this app is designed to be an everyday experience. Like it's supposed to be used during your daily routine, like your morning walk. So you come to an object and you scan it every day, and you get to see the story of the character that is bind to this object, and their story is developing. So this is the first thing. That you will see with this donut hat guy. And if I go to next day, let's see how this story will develop. Okay, I'm a little far away, but the donut guy comes back with a donut sacrifice. However, the bird does not take it and is still attacking this guy. And the bird comes to the donut sacrifice in the end. Yep. And here's the guidelines that we followed during our development. And next, we'll be talking about the details in our progress.
The programmers were given the task to improve the performance of Snobbug. However, before we get into that, the first thing the programmers had to do is to restore the original version of Snobbug. There were several teams working on this project before us, and some of the materials were lost during the transition from team to team. With little help from documentation, we had to dig deep into the complicated Unity projects and codes in order to figure out how to put this project back together. After hours of hard work and reaching out to the former developers on this project, we were able to restore the original version. The next thing the programmers were working on is the object detection machine learning inference system in Unity. The original system used TensorFlow, which is a third-party inference system, and we decided to change that, update that into Unity Barracuda, which is the official inference system developed by Unity themselves. The reason why we do this is because TensorFlow were no longer supported by Unity anymore, and using the official tool provided by Unity will give us long-term support. Also, we updated the machine learning model structure from Inception v2 to YOLO v3 for better accuracy. However, when we're trying to import our custom-trained YOLO v3 model into Unity, some errors occur because some of the features were not fully supported by Unity yet. This is a known issue for Barracuda developers, and they are working towards supporting these features. But it is still a work in progress, and they don't have an ETA for the fix yet. We tried different methods to solve this problem, but we did not succeed. Fortunately, there is a standard YOLO v3 model that can detect most of the items that we want to use for our object detection. And under the time constraint of a project semester, we decided to use this standard YOLO v3 model with Barracuda as our compromise so that we can finish our project on time. We relinked the objects with our animations and documented the implementation of this feature for our client for future reference. Furthermore, the original version of Snobbug are doing object detection function constantly, but it is actually redundant when the animation is already triggered. Therefore, we opted to turn this function off during the experience and so that the overall performance of the application can be improved.
Hi, let me talk about the interface. So in the original version, we only had the testing UI interface, which is not beautiful. In the interim design, there's no any tutorial animation and no any hints during the experience. And so in the final design, we add some new features. So what we learned from the playtesting in this semester, we did many of playtesting and we learned a lot. Although our user group are not naive guests, and they all had the experience about the AR technology, they still get confused what's going on here and how to use the app if there's no any clear tutorial or no any prompts during the experience. So we decided to add the hinting system in the experience and add the tutorial on the main page and the loading page. So let's talk about the animation on the main page and the loading page. The purpose of the animation is to tell the people what's going on here and how to use the app before the experience starts. At first, we used the black and white animation here, but we want to attract more attention from our users, so we decided to use a colorful one. So let's talk about the hinting system during the experience. At first, there's no any prompts or hints during the experience, so people easily get confused. What's going on here? What kind of object can be scanned on the street? So we put the hint in the bubbles and fulfill the screen. But people also get confused by the placement of the bubbles. And so our solution in the final is we only put 3 bubbles with the hints and at the bottom of the screen. So let's talk about the scanning frame UI. At very first, only testing UI we had. And then we put the blue square on the scanning area. Just tell the people, oh, the cell phone is working. But people easily get confused because there's no any feedback from the blue square. So we can see in the final version, we redesigned the frame UI, the scanning frame UI, which is very colorful. And also you can see there's a magnifier. It's moving around in the detection area. Just tell the people, hey, hold on a second, don't walk away. Continue to do that. And so let's talk about the final design. We can see the background is semi-transparent because we feel like semi-transparent is more fit in our AR topic. So that's why we did that.
So next, I'll talk about the character customization option. And these are the swappable body parts that we designed, which considered the parameters of not being cliche, and they needed to be modular. So we used the motion capture studio to collect a lot more data for the animation in a short amount of time. And here is the example of the donut head scene 3. The video is a screen capture in Unity, where you can see all of the combination of the donut head for the character of mix and match. The combination also works for the fox head and the robot head, just with different combinations. As Robin just showed us the previous things during the demo, now you may have an idea of how the whole donut head story is. And when we work on the animation, one of the issues was the animation targeting obstacle. Unity requires a specific amount of bones to work, which is not the same as the skeleton you get from the mocap data. To remove one of the skeleton joint, in this case the spine 3 joint, would lose the smoothness of the animation from mocap. Another issue we faced was the translation process works in Maya, but it creates an eye key issue where the knees would bend outward instead of forward. So what we did is keyframe editing and adjustment to the character's bone length, so the mocap data could be applied smoothly on our own characters. And for the foxing, here are the 2 examples of the foxing. We focus on creating different props for the fox magic show on the street. So once the user chooses the fox head during mix and match, one of the scenes would be triggered by the ground plane randomly. On the next day, you will get to experience another different magic show.
And in Maya, we give each object a skeleton joint, and then we keyframe those skeleton joints for animation. Some of the props actually have more than 100 skeleton joints, for example, the heart one. So the animation of those props were time-consuming, but the results were actually worth it.
So I'll talk a little bit about the other lessons learned over the course of the semester, one of which revolved around story. So the artist focused on getting the tech and the characters designed first, which pushed what the characters would be doing back a little bit into the semester. So at this point, we had to be creative and give the characters something to motivate them during the scene instead of having them backstories to push them forward. Another issue that we tackled over the course of the semester is not relying too heavily on departmentalization. This worked early on, allowing us to focus on details of the project, but not looking at the project as a bigger picture. This likely happened due to some of the tasks that we were given at the beginning of the semester that we decided to focus on. Another struggle that we had was balancing rapid prototyping versus large build times. So the project itself took a long time to build due to the complicated nature of the project. And also, because this is an outdoor experience, weather is not always suitable for playtesting. Even sunny days are actually bad because of the glare it puts on the phone. So partly cloudy days tend to be the best for playtesting. So to combat this, we did do some paper prototyping as well as creating indoor items to substitute for these limitations. So we also had a few ideas for the vision of the future of this app. We all have these ideas documented for our client to move forward with after the project semester has ended. A few of these are sound and vibration as indirect control. Using the custom snob is actually a way to give a tutorial for how the app actually works, and as using the custom trained models that the programmers have made during the semester. A special thank you to our instructors, our clients, our playtesters, our faculty consultant, the ET faculty and staff that helped out with our project, as well as Justin Macy, who helped us very much with the motion capture pipeline during the semester. Thank you, and do you have any questions?
Okay, so the question is to elaborate more about the machine learning process. So the backbone of this application is we do object detection on the street objects, for example, the fire hydrant and stop signs and stuff. And then when the object is detected, also when the AR get enough environmental point to construct the virtual environment, then the system will put the animation into this virtual world, and you can see in the AR. Yeah, and so like the floor detection is one thing, and object detection is another, and they are all important component in our system. Yeah, thank you.
What was the hardest problem you solved, and what was the hardest problem you didn't solve?
I can answer the hardest problem we didn't solve. Let me repeat the question again. So what is the hardest problem we solved, and what is the problem that we didn't solve? And so for the problem that we didn't solve, as I mentioned in our presentation, is the machine learning. We didn't really get to import our custom trained model into it. So we still got it work. We still got a somewhat updated version of the machine learning system, but it's not the complete version, and we want this feature to be complete later.
So as far as one of the hardest problems that we did solve is using the retargeting process that we did actually learn and have fully documented for the client to use in the future. That is also, we did use the full proof of concept that we promised at the beginning of the semester for mix and match in the future designated by the app. And I would say,
yeah, so at first, our requirement from our clients is intuitive UI, which means just as less as elements we have in the UI as possible. However, after we did many of the play testing, we found that we have to put the tutorial animation during the experience, and also give the prompts to the users to give them the clear whole picture what's going on here and what's the operation process in this experience, because that's the necessary. Yeah. Thank you.
Hello, we are 7 Season Studios, and we are the game pre-production project for spring 2022. I don't know why I put fall. These are our instructors, and this is our team. The goal of 7 Season Studios is to explore the process of creating an original game idea that would attract the interest of potential publishers. Our metrics matrix are documentation, prototype, and art style. Our main deliverable is a pitch that we would show to publishers and would potentially take us to the second meeting. And to show you the pitch, I'll hand it off to Lachlan Belford.
Thanks, Ryan. As Ryan said, we are 7 Season Studio, and today we are pitching you a game called Duet. Duet is a 3D puzzle adventure game for console and PC. It will be a 5 to 7 hour linear experience for young adults with an interest in music. But it will also be appealing to any fans of games such as Journey, Abzu, Rhyme, or the Legend of Zelda series. In Duet, when the giant whale you live inside contracts a deadly disease, it's up to you to nurse it back to health with the power of your healing music. In the world of Duet, music is a magical life energy that flows through this whale's body like blood. And you are part of a society of musicians that has built a life in the world inside of this whale. But now, the whale is sick with a disease that is disrupting its ability to sing. As its music drains away, more and more of your society has been forced into hibernation inside the whale's heart. Finally, only you remain. It's up to you to cure the whale and save your people. Fortunately, you play as the high priestess of your society. You have been specially trained to use your instrument of choice, this pipe organ worn on the back and controlled by keys on your wrist, to play music that activates the whale's immune system. The immune system takes the form of this crystallized musical energy that has coalesced in the affected areas and created 2 types of crystals that will help you. One that can be tuned to individual notes to reshape the environment, and the other that will amplify the sound and power of your musical healing songs. This is what you do in the main loop of the game. You enter a part of the body that has been taken over by disease, such as the lungs or the vocal cords, and you use your music to manipulate the environment and create paths forward. You then study the disease to learn the notes of a healing melody that will cure it in this area, and then you perform that melody into the amplifying crystal to cure this area of the disease. You will go through this loop several times, gathering these little bits of music, and then you will arrange them into a full healing melody that is powerful enough to heal an entire organ. So, for example, the first level of the game takes place in the whale's lung. You go here first because at the beginning of the game, the whale is having a lot of trouble breathing. The theme of this level is navigating the respiratory tree, jumping across the treetop canopy of its bronchioles and alveoli. So when you get here, you target these individual crystals and play music into them to move these branches closer to you or farther away, to inflate or deflate air sacs and create paths for yourself. You then target small clusters of the disease, which you will notice are recoiling from a particular note. And this note becomes the next note in the melody you're crafting. Once you have all the notes and they appear on your sheet music interface, you go to the central large crystal and perform this melody into it, which will heal the area, taking it from this corrupted, sick state to the healed state, where the musical energy is flowing freely again. You will then take this small bit of melody, which is playing very quietly right now, and then you will combine it with the other pieces that you've gotten in the lung. There will be a total of 10 pieces in this level. This is an example of how 2 of them would fit together. But once you have this melody, it's not enough just to perform the melody. Instead, you have to perform it in a duet with the whale. You will return to its heart and to the tempo of its heartbeat. You will perform this song together, with the whale filling out the bass notes and the harmonies that creates a performance powerful enough to heal the entire lung and prevent the disease from growing back there again. As you go through this loop, we want the player to discover that there's this 4th verb tying together everything they're doing in this game. It's all part of learning to communicate with the whale through this universal language of music. As you manipulate the environment and learn individual notes, you're exploring your basic vocabulary. When you heal individual areas with short musical phrases, you've learned enough to express simple thoughts. But by the time you're performing these duets, suddenly you're in active communication with the whale, and you are completing each other's musical thoughts and working together to create complex expressions. And this is also how the game gets more complicated over time. At the end of each level, you'll learn a new ability that increases your ability to communicate in this musical language. You will be able to play chords instead of just individual notes, allowing you to manipulate multiple parts of the environment at once. You'll learn to transpose your music into multiple key signatures, and you will learn to create overtones that allow you to extend your capabilities past the natural range of your instrument. In the final level of the game, the disease takes direct control of the whale's ability to sing, leaving you unable to perform the final duet. So for the last level, your objective changes to constructing a song of waking that will rouse the rest of your society. When you return to the heart and play this song, the members of your society will wake up one by one, pick up their instrument and join your symphony. And altogether, your song will become powerful enough to free the whale from the disease's grasp and cure it once and for all. This is Duet, the game we're hoping to make. And to talk more about what we need to make it, I'll hand it over to Justin.
Thanks, Lachlan. To recap, Duet is a 3D puzzle adventure game for the console and PC. In terms of specific development, the Rhyme is the most similar game because it's also a puzzle adventure game that's around 7 hours long. Inspired by numbers from Rhyme's development, we expect the development cost to be $12.6 million. We plan to sell the game for $40, which, factoring in platform and sales cuts, comes to around half that in revenue per unit. This puts our break-even at, This puts our break-even at 562K units sold, where we expect to sell 750K units on the low end and 2 million on the high end, which means we anticipate that our game will be profitable. That is the end of our game's pitch. Now going into more detail about our fiscal exploration, our strategy for determining our development scope was to pick out similar games that are most similar in terms of implementation-wise. Here are 3 games we use as references and the data that we extracted regarding their development. Since much of this information is not public, the team had to do a lot of digging through articles and retrospectives to find these loose ballpark estimates. Once we identified the development scope, the next step was to determine the development cost and expected returns. This also required the team to do a lot of research into industry standards. Additionally, to validate our break-even number, we went back to our reference games and compared our break-even against the estimated sales of those titles. Finally, we performed a SWOT analysis to make sure that our game had its place in the market. Next, I'll hand it off to Damien to talk about our design process.
Thanks, Justin. So for the game iteration, the first thing we need to make sure is that what kind of game we want to create. At the beginning, after several discussions with each other, I found that all our teammates have a passion of the adventure game like Zelda, so we decided to do an open world adventure game. But after team meeting, we found the scope is too big. We don't have enough time to create that kind of game. So we decided to do a linear story adventure game. But we still think our game lacks some interesting part in our game. So we decided to add some music element in it. And for the discovering the appealing, our first goal is to attract as more as we can the players. We want to make all the players feel it's interesting for that. So we need to learn some basic design from the traditional adventure game like Journey, like Zelda, something like that. And then we also need to have our unique element, like for example, the music, to track the musician players. And so we get some inspiration from the Wonder Song and Opus. And we faced some difficulties during the teamwork, and there are 3 questions we need to answer that. The first thing is how to ask a question. Like at the beginning, everybody have a lot of doubt about that, so we need to ask a question in a smart way. And finally, we overcome these challenges. And the second thing is to how express your opinion. Everything is it's unfamiliar for us, so we didn't familiar with each other. Our personality is too gentle, but finally we decided to express our opinion directly. The last question is how to make a decision. The first thing is our design team will finish the design document with each other, and we will discuss with the artist, and we will make the decision together. The next part is about art. I will hand Harry to talk about it.
Thank you, Damien. So for art, we focus majorly on 3 aspects: targeted concept iteration, environmental design, and character design. So for the targeted concept iteration, we want to narrow down the range of our concept and touch on the things that we haven't touched on before, which include the corruption within the organs and also the exterior look of the whale. We do this to visualize the design and also to satisfy the reference for future 3D modeling and rendering. Next, I will give Ivan to talk about environment.
Thanks, Harry. When thinking of what kind of visuals to include in this game, it is really important for all of us to keep in mind that the players stay inside of a whale. So we looked up the anatomy of a whale, and we also found different reference images from online to help us to develop our concept arts and sketches. We were also trying to avoid showing an unpleasant feeling to our player. And when we designed the concept arts of the different environments and the landscapes using 3D modeling tools, we wanted to create an atmosphere of mysterious and exotic by utilizing different shapes and vibrant colors. And for instance, in this case, when we designed the surroundings within the whale's lawn, we drew inspiration from the structure of broccoli. And we also incorporated other natural elements such as trees and mountains. We thought to employ vibrant colors and a variety of lighting sources to ensure that our player had a good time exploring the place, and also we wanted the environment to be visually appealing to everyone. Besides, we also attempted to create a contrast between before and after to showcase and emphasize the player's ability to clean up this area and to re-energize the plants and the environment. And to quickly touch upon the user interface design, we wanted to include many aspects as possible. For example, we included an icon to display and indicate the sheet music, and we also included a map to help players easily identify their previously visited locations. And for the next part about character design, I will hand it off to Joy to talk about it.
Thank you, Ivan. We had a few iterations and explorations during our character concept design. Considering of the culture and technology level of this world, also the social identification of the character herself, we designed her clothes into a set of inner suit and a cape with symbols of the whale. Also, her wearable pipe organ was designed like a small wing, which is also a symbol of healing. To fit the overall low poly style, We modeled our character into an hourglass shape, which also cut more light and shadows to have the overall effect look nicer. We also have some concept animations to show how the character plays the notes and move around, also climbing to a higher location in the actual gameplay. Next, I'll head back to Ryan, talk about our production.
Thank you. So now let's talk about how this project actually went down during the course of the semester. So this is how we came into the project expecting that it'd happen. Each of us would step back and would go into our individual roles, and through good communication, would be able to pull together into one singular pitch. But that's not exactly what happened. There's a lot of dead ends, wasted work, designing in circles, and more in order to chisel out like what this project actually was. And that's just what pre-production is. It's messy, it's inconsistent, and it's wildly unpredictable. And to that end, each misstep wasn't a failure. It's a success and a moment of learning. Because what we were learning isn't exact steps to have a successful pre-production phase. That doesn't exist. We were learning how to bring an idea to life, what we needed to know, what we needed to make the audience know, and the tools to help us along the way. We want to give a special shout out to everyone who's helped us along this journey. We are 7 Season Studios, and we're open for questions. Thank you. So the question is about prototypes. I can answer that a little bit of production-wise. So initially, when we were given this project, we were kind of warned that we were supposed to stay away from a demo because there's obviously costs of implementing a demo. But about week 6 or 7, we were kind of realizing that our lack of a technical demo was not really helping us in visualizing what the gameplay was. So it was at this time, which is after halves, which is not ideal, that we really started thinking about white boxing and using that as a way to developer design. Through weeks 8 and 9, while we're working on the white box, we ran into a different problem of game production, which is sorry, I'm getting a little bit off tangent, but hopefully this is interesting. We got into another problem of pre-production in which the things that we thought about earlier in the semester have become obsolete due to the inevitable pivoting. So we were designing our white boxing level design off of kind of an outdated level concept. So in weeks 12, 13, 14, we were working on this. We tried to make another white box. Sorry, I've been flipping the slides because I've been trying to get it all the way at the beginning. We were trying to make a white box off of this design, which is the one that takes place in lungs. So we had Justin in Unity try to white box and block out the things that are important if you are like standing in the scene. And so by that time, it was kind of difficult to make it playable, but we really wanted to do our best to, like, at the very least, put it in the game engine and visualize what it's like to actually be in the space. So to make a long story short, initially we interpreted advice as we should not do it, but then throughout going through the project, we realized that it would have been a good idea given the status of our team. And so we tried to get there, but it was not enough time to completely visualize the interactions. Does that answer your question? Cool. Any other questions? Yes.
Can you talk about a breakdown of the time you would expect the player to spend on different activities? Like what percent of time on the music, what percent of time on other activities?
Yeah, let me just repeat the question first. So the question was, can we give an explanation of how the player themselves, as they're playing a game, what their breakdown of playing music versus other parts of this game? And to this, I'll hand it off to Lachlan.
Yeah, we want each organ of the game, of which there'll be 5, to take about an hour to complete. Each challenge level where you're navigating this environment, moving things around with your music, should take about 5 minutes to gather, on average, to gather these notes, move around the environment. And then the moment in each individual challenge where you're performing the music into the crystal, that only takes 10 seconds or so. At the point where you've finished the level and you have gathered all the pieces, you're basically just solving a jigsaw puzzle to like put together the music that you're performing. That should take about a minute, and then the music you are performing at the end it will be about a minute long total. All the pieces you've gathered will add up to about a minute of music.
Okay, sorry, I just want to understand this better. You said a level takes about an hour, right?
Yeah.
Give me a pie chart of like what you talk about 1 minute here, 1 minute there. Okay, what about the other 55 minutes? Can you talk about like what is the breakdown of that pie chart in terms of how player activity is spent?
Yeah, so you enter one of the puzzle areas like this, and you look for, so there's some time spent observing, like what are the things I need to collect? There's like little bits of disease that will teach you the melody. There's your final goal, the main crystal, and then there's the things you can interact with, the branches you can move around, the air sacs you can inflate and deflate. So probably about a minute of discovering what's around and what I need to go do, and then, you know, the rest of the time is targeting something, playing music into it, discovering its range of motion. Like you play a note in the middle of the scale, it goes somewhere. If you slide it down, it'll get closer to you. If you slide it up to the top of the scale, it'll move away. So sort of discovering the range of each of these things you can manipulate, and then creating paths for yourself and jumping across the paths, and then targeting these bits of disease and destroying them, which is a simple interaction that only takes, you know, 30 seconds or so to do, but yep, thank you.
All right, that's time. Thanks, Steve.
All right, thank you very much.
All right, congratulations to all the teams who went today. Good job. And back to you. We'll go to the boardroom. Steve, tell me about that throwable microphone.